Here I'm going to go over how to design this pipe elbow. In short, the approach I'm going to take is to design this face here, this mounting face, and then mirror that face to create this one here. And then I'm going to use a new technique to extend and make the tube part. Looking at the dimensions, we see that it's 360 millimeters square, 50 millimeters thick, with these counterbore holes. Basically, the through hole is 30 millimeters, but the counterbore, that's what this symbol is, the counterbore is 60 millimeters and it is 10 millimeters deep. So I'll show you how to work through that. So going to Inventor, we're going to make a new part, a new millimeter part. And starting a 2D sketch, the XY plane, we'll make a centered square here at 360 millimeters. And we'll make the other dimension 360 millimeters. Now, we'll talk later in this assignment about parameters. Right now, instead of typing 360, I'm just going to click on this and hit check mark, and that defines them both to be the same size. And so if I changed the first dimension, it would change the second so that they're equal. I'm just going to immediately extrude this, and I'm going to extrude it 50 millimeters. And for right now, I'm going to extrude it in the positive Z direction. You can do in the negative Z or symmetric. I'm choosing positive Z because of how I want to do the mirroring later, but either one of these would work. Creating that, I'm going to make another sketch, and I'm going to just do a project geometry and an offset, and in 50 millimeter offset I'm going to put these points at each corner. And so notice with a single dimension I can define the location of all four of these points. They're in from each corner at 50 millimeters. Then I can hit finish, and I hit the whole feature, and here I can choose the counterbore, and it's just remembering what I had when I first designed the part. So basically the way you do this is choose the hole. We don't want a threaded hole or anything. We basically want a simple hole, but the seat we want a counterbore, and that's this part right here that has a wider diameter and it goes a certain depth. The counterbore diameter is 60 millimeters, the depth of the counterbore is 10, and then the depth of the through hole is 30. And that's how we can make that. We also need a hole in the middle that is 210 millimeters. I could have made that in my initial extrusion, and in fact, why don't I go back and just double click here and make that. I could have done that in a separate sketch, but let's just make it in the original sketch. I will need to edit my extrusion, and so to do that I can double click on the extrusion and just deselect the center hole, and that I can just go control click, and that makes this. Then I'm going to add the fillets. Looking at the drawing, the fillet radius is 20 millimeters on each corner, so I'm just going to go here, set it to 20, and then select each corner. And then hit OK. So now I have this piece. What we'd like is you can see through the part here that really this is just a repeated piece over here, and so it makes sense to mirror that piece. What I'm going to do before I mirror that piece is I'm going to draw this little arc here. You can see that it is 100 millimeters straight, and then we have this curved radius that's 210 millimeters in radius that creates this 90-degree arc, and then we have another 100 millimeters where the other flange or mounting plate is where it starts. And so basically, I'm going to draw this shape in a sketch. Then I'm going to create a couple of planes, and I'll demonstrate that so that I can mirror this over here and make a copy, and so they're linked. And so if I ever change the design here, it would update it here, and so I'm not really designing it twice. So what I need to do is draw that arc. So the first thing I'm going to do is find a plane that allows me to do that, and that looks like this plane. And so I'm just going to select that plane and create a sketch, and then start drawing. And I'm going to be careful that this snaps into the middle. If I don't, I would need to use a constraint. So let's say that I just drew some line, just random line like this. You could force it to be in the right location. The first thing I would do is make it horizontal. Notice that my horizontal is actually vertical here, and that's because of the plane that I chose. It's just rotated, so I'd actually need to do the vertical constraint to make this line side to side. Then I'm going to select this point and this point to make sure that they're aligned side to side or horizontally. And then I'm just going to do a coincident constraint from here to here, and then dimension that to 100 millimeters. Next thing I'm going to do is just draw an arc, making sure that it attaches here. It goes somewhere over here. We'll find that later, but we know that the radius is 210, and we know that we want this line and this curve to be tangent. Then I'm going to make a line here that is 100 millimeters long, and we want it to be vertical. And instead of typing in 100, I'm just going to go here and make sure that these two are the same. And I need to make sure that it is vertical, but since this is rotated, I need to use a horizontal constraint. If that bothers you, you could just actually rotate the part like this, and then I can choose this horizontal constraint like that. Make that. It looks like that constraint already exists, which is great. I do want to ensure that the endpoints are touching. It looks like that they are as well, but if they weren't, I wanted to make sure that they were coincident. And the final thing I want to do is make sure that this curve is tangent to this. And so hitting the tangent, clicking here and here, we can make that tangent. What that curve allows me to do is define the plane, which would be right here, which would be the start of the new flange or this mounting base. And so we're going to mirror such that it starts at this location and extends out over here. So to do that, I'm going to finish the sketch and go to the plane tab. And basically what I want to do is create a plane that is parallel to some other plane and through this point. So specifically, I want that plane to be parallel to this, but I want it to go through that endpoint. So I created this new plane here. You can see that. And that is going to be the beginning of the face of the plane that creates this new mounting plate here. Then the next thing I need to do is create a plane where this mirrors about, which needs to be a mid plane that goes basically here at 45 degrees. And so what I'm going to do is on the plane tab, I'm going to say create a mid plane between two other planes. So I'm going to click this, and I need a mid plane between this plane and this plane, which gives me that. That is going to be the plane that I mirror all these features about. So the next thing I'm going to do is click the mirror. The features I want to mirror are my original extrusion, the holes, and the fillet, and then the mirror plane is this plane here. And it kind of pops up here of what it gives me a preview. Everything looks good, and so now I'm going to hit OK. So now I have basically the two mounting flanges, and what I need to do now is to make the circular part that extends. And to do that, we're going to use something called a sweep. And in short, what we're going to do is draw what we want, the shape we want, which is basically a circle, and then extend it to this part through the sweep feature. So I'm done with this plane, so I'm going to right click and go visibility. And in fact, I'm done with this plane, so I'm going to right click and go visibility on that one so they're not showing up. Notice I have the sketch just hanging here. We're going to be needing that when we do our sweep, but what we need to do is create what feature we want to sweep through this arc here. And looking at this, basically you can see that we have the 210 diameter, inner diameter that represents the inner diameter of that pipe, and then a 260 millimeter outer diameter. And so what we want to do is make sure that we just put those two dimensions in, and then we can extend that arc through. So going to our drawing here, we can create a new sketch on this plane. We know we have the 210, and I can just draw that, or I could have projected geometry because we know that that inner diameter is 210 there. And then we have our 260 here. 260, I think. And so we have those two, and so we should be able to now finish this, hit the sweep. The feature we want to sweep is this, and the direction or the curve that we want to follow, that profile is this profile. And then it can kind of sweep through, and we hit OK, and we get that general shape. And the final thing we're looking at is the fillets. Okay, so the filleted radius is a, let's see where that's at. It's written here. So, or not fillets, but a chamfer, a 10 millimeter chamfer, 45 degree chamfer. You can see it a lot easier in the 3D model. It's these chamfers at each opening. So I'm just going to do that. I could have done that earlier on this face and then mirrored it here, and that may have been a little cleaner. In fact, that's probably what I should have done. It really doesn't matter too bad, but we can just go 10 and make that fillet there, and then this fillet here, and go apply. What we will do in subsequent videos is talk about how we can add parameters and name the actual dimensions, and then we can make an eye part, which allows us to make adjustments to this when we make an assembly. And so when we place this into an assembly, we can change its size based upon the settings we choose.